This is programming in Java, and in the last class we are talking about the variables, and we discussed about what variables are, and then we talked about type conversion and casting. So in the type conversion, we said that we have automatic type conversion also. Generally, what you call we can convert a lower, a value assigned uh, to a lower type to a higher type. From a lower type to a higher type, it will get automatically assigned, but not vice versa. Vice versa, when you want to do it vice versa, then it should be by means of explicit casting. But when we do casting, we should be very careful because it should not get truncated. The value will get truncated. Sometimes if we try to do the so to say typecasting, sometimes we call it as casting or typecasting, explicitly. Okay, explicitly, whenever we do from a higher type to a lower type, there is a chance of truncation, or so to say, modulo is what will come out there, or the fractional part might get dropped. Okay, that's what we have seen. So basically, automatic conversion is widening conversion, and casting is narrowing conversion, which we have seen. So we have seen the example for the same also, and we have seen the result of this also from the book. And further to this, today we'll take up the automatic type promotion in the expressions, and then if time permits, we'll go through the arrays also. Okay, so whenever we use expressions within expressions, what you call variables which are of different types, then naturally it is the higher type which will be the end result. Okay, whenever we use within the expressions, what you call variables of different types, then automatically it will get converted into a higher what you call type. Okay, so it's basically automatic again. Okay, not casting. You don't need to cast it automatically. It will happen. In an expression, the precision required of an intermediate value will sometimes exceed the range of either operand. So under that case, it will get promoted. Okay. So for example, byte A is equal to 40, byte B is equal to 50, byte C is equal to 100. Int D will be equal to A into B A divided by C. So if you just see A into B, 40 into 50 will become 2000. 2000 cannot fit in a byte because a byte is only 8-bit value, which is from 0 to 55 if we take only positive values. However, if you want to include negative values also, it will be minus 128 to plus 127. So the value of 40 into 50, which is 2000, cannot be fit in a byte. It has to be put in a integer. But however, we might divide it by a value 100 later, but that doesn't matter. First, it is multiplying 40 by 50 and then divided by C. Not only that, we see that all the what you call bytes as well as short will get converted into integer automatically in Java. Okay, so here A multiplied by B easily exceeds the range of either of its byte operands. Also, Java automatically promotes each byte or short operand to int when evaluating an expression. So whenever we use a byte variable or a short variable in an expression, automatically it will be converted into an int, and then the evaluation of the expression will be done, and accordingly we will have the what you call assignment, so to say, to some other variable, the expression. Okay, that is very important. Okay, so they can cause confusing compile time errors. These things can cause confusing compile time errors also. For example, if you have byte B is equal to 20 and B is equal to B into 10. Now, if you see here, B is 20, 20 to 10 is 200. 200 is still within the range of byte, but automatically this B is converted into a integer. This byte value is converted into integer. But now you're trying to assign it to a variable which is of the byte type. So an integer cannot be assigned to a byte type, and hence, you'll get an error, cannot assign an integer to a byte. So whenever doing expression evaluation, a byte or a short will automatically get converted into a integer type of variable. This is rather very important. Okay, so in this case, so you can't have this kind of thing. So in this case, we need to do explicit casting. So in this case, the operand were automatically promoted to int, and the result is promoted to int, which cannot be assigned to a byte without the use of a cast. So in case of such overflow, an explicit cast has to be used. So we need to write here, casting. Casting means within the bracket, we try to write the type over here. Okay, so this B into 2 will become 100. 100 is now of integer type because B is a byte type. It has to be explicitly casted. Okay, even though 100 is not within the, it is within the byte range. Whenever expressions are evaluated, a short or a byte will automatically get converted into an int in Java. This is rather very important. Okay. So type promotion rules we have. Java defines several type promotion rules that apply to expressions. All bytes and short values are promoted to int. This is the first statement, which is very important, which we have just discussed. If one of the operands is long, the whole expression is promoted to long. If one of the operand is float, the entire expression is promoted to float. If any of the operand is double, the result is double. So this will be the set of statements in the order in which it should go. Okay. If we have byte and short, those things are automatically promoted to int. If one of the operand is long within that, it will become long. One of the operand is float, it will become float. One of the operand is double, it will become double. Okay, this is very much important. So this is a simple program which we have over here. Byte B is equal to 42, character C is equal to A, short S is equal to 1024, int I is equal to 50,000. Each is within the range, right? Float F is equal to 5.67 F, double D is equal to 0.1234. And then we are writing here double result is equal to F into B plus I divided by C minus D multiplied by S. Now see this over here. We'll come to this a little later. See this over here. F star B. F is a float and B is a byte. So you're multiplying a float with a byte. So effectively, this will become a F multiplied by B will be a float value because float is a higher type. Then I divided by C. I is integer. Yes, C is character, right? C is character, which will be automatically it will take a value which is nothing but the 8-bit value over there. So now it is of the we have the this will become of the integer type because integer is of higher type. Then you have D, which is double, and S is the what you call short. So higher type is double, so this will become double. So double, integer, float. Okay. Now when we add the float with the integer, then float is higher type, so it will get converted into float. When the float is minus the double value, we are trying to do the higher value is double. So therefore, all these things should be double. And hence, it should be assigned to a double. Say if you write a float here, or int, or whatever, then it is going to give again an error. Okay. It will just give you the error indicating that a double value cannot be assigned to a integer result or float result or whatever. Okay, so this should be very clear, right? So F into B, float into byte, higher type is float, I divided by C, int divided by character, higher type is int, double multiplied by the short, higher type is double. So float and integer added will become, it will be converted into float, the sum of those two. Then subtracting a float, double from a float will give us a double, because double is of higher type. And hence the result, to which this, the result variable to which this whole expression is assigned, right, should be of the double type. It cannot be float or say int or char or whatever, right? So now we are just trying to, it will just give you the values. It will just try to, find out, that is f into b. It will calculate 5.67 into the 42 value and print over there. And then plus, this plus is a delimiter. And then this plus is the string, literal string, or rather you can say a character. Okay, this is a character which will be printed. Then again, this is a delimiter like comma. Okay, this is a delimiter like comma. This is a delimiter like comma, but this is not a delimiter because it is within quotes. It's a literal character, right? Then again, you have a delimiter, but this minus is a again character, so it will print that character itself. Again, this is a delimiter, so it will print the value of b star s. So whatever double value will get here, whatever float value will get here, whatever integer value will get here, all that with plus and minus in between them. Okay, float value plus the integer value plus this plus and a integer value minus the double value, okay, is what it will print. Okay, and then the result will be equal to plus result. Plus is again a delimiter over here, so it will result equal to is within quotes, which is a string type of literal over here, and that will print. And then this is the variable, that means the whatever value is assigned over here, that it will print. So you can write this program and run. Okay, so that is what we have over here. So next topic which we'll go for is the arrays. So what is an array? An array is a group of same type, like type. Like means same type of variable, types of, you can say variables of similar type, variables of similar types that are referred to by a common name. A group of variables of similar type or like type variable. So this is a little funny type of term, like type. Might be able to have said group of variables of similar or same type, rather. Same type means integer or float or short or whatever. Okay, which are referred by a common name. We refer it by a common name. A specific element in an array is accessed by its index. So to access a particular element of an array, okay, we have a group, and within the group, if you want to access a particular element of that group, then we need to use its indexed. Okay, index. So a one-dimensional array is essentially a list of like type variables or variables of same type. General form is type here, int variable name you can write, and then you write a square bracket. Okay, we don't mention anything in the square bracket here. Type declares the base type of error. Type declares the base type of the array. The base type determines the data type of each element that comprises the array. Okay, so this just will give us the base type determines the data type of what is the data type of this what we call each of the elements which corresponds to that array is being mentioned over here. For example, int month underscore days. Okay, for example, a month like January days, if you say, then you can say that it is 31. Okay, might be February days, might be 28 or 29, depending upon whether it's a non-leap year or a leap year. Okay, something like that. So the value of the month underscore days is set to null initially. We set the value of the month underscore days to null, which represents an array with no value. So we have not assigned the value to this. So to link month underscore days with an actual physical array of integers, okay, to link the month underscore days with an actual physical array of integers, you must allocate one using new. So we should use the term, operator, new operator. We should use the new operator to, so to say, allocate and assign it to month days. So new is a special operator to allocate memory. Okay, new is a special operator that allocates the memory. The general form is array underscore var equal to new type size. So earlier we have written type month underscore days, or if you take array variable, then type array var, and the using the new operator, we can assign the memory to it for using this. You can join this, both the things, allocation of the memory as well as the, so to say, type declaration, both together also, by writing here might be, type array dash var equal to new type size. So to use the new to allocate a what you call an array, you must specify the type and number of elements to allocate. So month underscore days is equal to new int 12. So how many months are there? We know that it's 12. That's why, might be you can take it. Really speaking, it should be, when you mention 12, it will be 0 to 11. It can take 0 to 11. Size of the array is 12, but it will take from 0 to 11. It's starting, element is always 0 for an array. Index is 0. Okay. Obtaining an array is a two-step process. Declare a variable of the desired array type. Declaration will be type variable name. Allocate the memory that will hold the array using the new and assign it to the array variable. In Java, all arrays are dynamically allocated. We see that in Java, all the arrays are dynamically allocated. So you need not explicitly allocate it, but however, it is good practice to, explicitly, allocate it by using the new operator. So once you have allocated an array, you can access a specific element in the array by specifying its index within the square bracket. For example, month underscore day of 1 is equal to 28. Okay, so this one will give us the February. February is having 28 days, so he's taking non-leap year. Say if he writes 0, then we know that 0 month 0 is January, and January has days which are 31, so we should write here 30. So all array indexes start at 0. This is rather very important. That's why, we have mentioned here 12, right? When we write 12 here, it means that you have 12 elements from 0 till 11. That will be the 12 elements. Okay. So 1 will correspond, 0 will correspond to January, 1 will correspond to February, 2 will correspond to March, and so on. Okay, a little confusion might be there, but that's how it is. Okay. Then we have the class array, public static void main string args, string colors. We are taking an example over here, a class of the type array, and within that we are using the PSVM, that is the main method string args. Then within that we are trying to write a variable which is colors, an array variable which is colors, using the string type of type, and then you are trying to assign 7 different array variables. Okay, colors equal to new string 7, because we know that in the in the so-called rainbow, we use 7 colors. Okay, from 0 to 6. 0 is violet, 1 is indigo, 2 is blue, 3 is green, 4 is yellow, 5 is orange, 6 is red. So VIBGYOR, we can call it as VIBGYOR. So that will give us VIBGYOR. Okay, so this V also you can make it capital. Somehow he has not made it capital. All the other letters R, O, Y, G, B, I, L, R are all capitals. So V also should be made capital. So see, it's a system.out.println rainbow colors plus colors I is there over here with a for loop. That means it keeps on printing, that so to say violet, indigo, blue, green, yellow, orange, red. Okay, this is a print statement which keeps on printing the values violet, indigo, blue, green, yellow, orange, red. Okay. So arrays can be initialized when they are declared. You can initialize them when they are declared. An array initializer is a list of comma separated expressions surrounded by curly braces. Okay. For example, we can write int month underscore day is equal to 31. January is 31 days. February is 28 days. Non-leap year 31 days for March. Like that, you can go on writing. Okay. You can go on writing. So if you go on writing, it will automatically say that consider that the month underscore days is having 12 elements, because index will be equal to 12. So the Java runtime system will check to be sure that all array indexes are in the correct range. Okay, it should be, when you write int here, then it should be within the correct range. If elements outside the range of array are type to be accessed, then a runtime error will be caused. So if you use a what you call floating value inside and put right into over here, then naturally it is going to create a runtime error. C++ provides no runtime boundary checks like that. Okay, Java provides boundary checks like that, but whereas C++ do not provide the boundary checks. Then we come to the multi-dimensional arrays. In Java, multi-dimensional arrays are actually arrays of arrays. Okay, the arrays of arrays, right? Array within array, sometimes you can call it, or arrays or multi-dimensional arrays, you can call it same thing. To declare a multi-dimensional array variable, specify each additional index using another set of brackets. For example, int 2D, so you have a two set of brackets here is equal to new int, one set of brackets you have 4 and other set which is 5. So totally, you will have a 4 by 5 array type. Okay, 4 by 5 array type, right? So you have 4 rows and 5 columns, right? So 4 rows are indicated by the left index and 5 columns are indicated by the right index. So this is how we will get the diagram for the same. I think we might have come to the end of the slide set over here. That is the problem. Oh, yes. So we'll go back to the book. Okay. This we already seen. Okay. So you can go through this program also, which was there here in the earlier one, right? Where we have written here a little differently, This we didn't take up. You can just see here month days in 12 and then for 031, January 31, February 28, March 31 and all that is assigned over here. And then, in the next one, we have till 11 and then we are trying to print. System.out.println April has month underscore days 3, okay, plus the whatever, days. Okay, days is naturally within the double quotes, so days will be printed as it is, and the value 31 will be printed by this. Okay, so it will print April has because it is within string. Then it will print the value of the month underscore days 3, which is nothing but, the what you call month underscore days with square brackets 3. So that will give us the value 31, which is taken from this program over here, right? So here you have month underscore day equal to 30, and that 30, sorry, it is April, so it is 30. It will print the 30 value. Okay, April has 30 days. That is what it will print. Okay, so similarly, we have the, this is another way of assigning, just a different way. And then you have the average also here. Average and array of values is written over here, and might be we are writing here double result equal to 0 int I, and then we might be using a loop to calculate the values. Okay, for I equal to 0, I less than 5, I plus plus, result equal to result plus num I. Okay, it keeps on adding that, so to say, 6 times. Is it 6 times or 5 times? 0, 1, 2, 3, 4. 5 times it's going to add. Okay, and then divided by 5. Divided by 5. Okay, so we have 5 numbers, add it 5 times, and then you divide it by 5 to get the average value. Multidimensional arrays is what we have here. So we are trying to, see the multidimensional arrays, public static void main, string args, 2D value, declaration, and the, so to say, allocation is being done over here. And then, ijk equal to 0. And then we are trying to assign the value for each of the 2D I comma j, that is equal to k we are trying to write. And then we are trying to print the same thing, right? We are trying to print the same thing. So thus it will give you this value 0, 1, 2, 3, 4. We are just going on incrementing the value here, k plus plus. That's why after 0, what comes is 1, 2, 3, 4, and then once one loop is over, it goes for the next loop because it is for within a for. So 5, 6, 7, 8, 9, then 10, 11, 12, 13, 14, then 15, 16, 17, 18, 19. So this rows, 4 rows are there because we have the index, first index here as 4. 5 columns are there. That is why the reason is we have 5 in the second index over there. Okay. So this is how, it's printed there in that format. Okay. Fine. While there is, okay, you can do something like this also, where, we have what you call allocated here, only the first index, second index is not allocated. You can allocate the second index by using the new operator separately. However, one should remember that, you can assign. In this case, we are assigning only 5, 5, 5, 5, 5. Here, you can assign, different indexes also here. So whenever different indexes are needed, we can use this. Okay, we can use this. So that is the advantage. You can write, see here 1, 2, 3, 4, 5. We have put different index over there, and if you try to print that using the program over here, you're going to get the result, which is something like this, right? You'll get like this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because the second index is different. The second index is different. Second index is different. So we have, we can just go through this program, you can see, and that's why, we have printed it like that. So the array created by this program will look something like this. Okay. Similarly, you can have a, what you call first initialize a, two-dimensional array, and then you can keep on increasing the size of the array. Okay, so here we have written here, what is that? 3 by 4, 3 by 4. Okay, so this is a two-dimensional array with directly assigning 3